this is the Ion platform for those of you who haven't seen it in the past. I'm actually in the integrations tab, which is basically a view into the integration space, like I said before. I'll start this by looking at like our parts library. So this is sort of the downstream record of all of the parts available to your production teams and your supply chain teams to go out and procure material, build material, establish bills of materials and do the execution related activities that you would do on a normal in a normal manufacturing environment. So Ion has its own library of those parts that are ready for production. The beauty in a platform like Duro is obviously the UI is very slick and easy to use, and it's really comfortable to get a hold of. But Duro is sort of where your engineering teams are controlling their processes for release. So this is the Duro platform. I've been working on this bearing assembly as a mechanical engineer. I'm changing a couple things about it. So I put in some of the lead time information, the unit cost. I've put in some product related data like the mass of this thing. Down below, I've actually established what some of the materials that go in to make this assembly are, along with their quantities and their level. So as you can see in this particular assembly, there's 4 BOM items. They each have their own quantities associated with them. So imagine me as the mechanical engineer. I've gone through, I've linked this out to my CAD software. I've pulled in this assembly, and now I'm actually ready to release this to production because maybe I actually want to go out and start procuring some of these or building some of these to do testing on them to ensure that they're working for our product line. So I've made the changes already. I think I've changed some of the quantities on these parts. But what
So
I'd like to show you before I do
Jackson, just
is,
just
sorry, go
before
ahead.
you jump in, if just to show the users, if you can show them the built-in diff tool, so on the upper right in the red triangle, excuse me, in the history, the clock right next to it, yeah. So you can
Right. Okay.
compare revisions and you can see exactly what's changed between those revisions. So you can see the changes that Jackson made down
Right.
below.
Yeah. So I changed the quantity from 12 to 8 on a particular BOM item. And having that diff is really key to understand what had changed, especially if there are multiple engineers working on this particular assembly at any time. Yeah. So the red triangle here is an indication that something has changed, and that they're going to ask me to go through the formalized change order process. And for those of you that don't know, the change order process is that formalized release process. So now that I'm saying it's ready, I want to maybe get some input before I push it to the downstream systems or whatnot. Before I do that, actually, I'm going to hop back over to Ion, and just show you that none of these parts actually exist in the system. So this 99, triple nine, 4 zeros and a 6 part doesn't exist in the library today. And you can actually search for that. I believe it's going to be here. So the 992 part does, but the 99906 part does not. Nor do any of the BOM components here exist. So I'm actually going to go through the formal change order process in Duro by clicking on the red triangle, adding this to a change order. There's a few different types of change orders: engineering change orders, manufacturing change orders, and document change orders. Engineering change orders are probably the most common, although Michael, you might have some more detail into that in particular.
Yeah, you're right. Engineering change orders are the most common. Typically, we guide customers. ECOs are appropriate for form, fit, or function changes. MCO manufacturing change orders are usually typically used for process changes. And then documentation change orders kind of a catch-all. So if it's anything from adding data sheets to fixing a typo, the document change order lets you keep track of more minor revision changes.
Right. So in this particular case, since I made some changes to, the bill of materials, and I may have changed some of the actual assembly attributes, I'm going to go with an engineering change order. And I'm going to give the change order a name. I'm just going to call this bearing release and then, give it today's date potentially. There might be some schema that your business chooses for naming this, but that's what I'm going to do for today. Um, I'm going to make sure that I select the correct assembly. And then I want to include the children components in this as well. So, um, the bearing is what the bearing assembly is what I'm actually, releasing, but along with, the subcomponents if there had been any changes to them as well. So, including all of those in my change order, I'm going to submit this for an approval. So now I have to go through the approval process. So you can establish certain guidelines for, who is going to approve these parts. I'm sure there's some workflows within Duro, based on the part type or,
Yeah,
on specific attributes of the part. You can have particular people within your business take a
correct.
look at those.
Yeah, you can apply different templates, and the templates can, be based on different workflows you have established. So it'll automatically add, approver lists, notification lists, and even approval types. You can even have mandatory templates. So you can have it enforced, either for consistency or just to make sure that no one deviates, where if you submit certain characteristics of components, whether they're in prototype or production, you can enforce specific templates to be implemented that can't be editable. And so it drives, simplicity and consistency. A lot of people look for.
Yeah, that flexibility is really important, especially if you have a quality critical product, as I know some of our customers do, where you want, you know, specific eyes on the product before you go ahead and release that. Or at least that's been my experience with it in the past.
Exactly.
So here's the sort of the approval screen. I am the only approver listed on here in this case, just to sort of speed up the process here. I have the ability to sort of approve, reject, and close this particular change order. One thing that I'll note, on top of the proliferation of the API and sort of the importance of it, is this idea of like the event-driven integrations. So both Duro and Ion have this idea, what we call a webhook, which is actually, whatever is going on in the system, you can actually listen for specific events that happen. I've gone in the background and I've established it's a very simple process, and Duro makes it very easy, but you can set up a webhook to listen for a specific event. The webhook that I set up was on change order approval. So anytime something is approved, it's going to take a list of product and components that were put onto that engineering change order, and then those approved products will be brought into the integration. So I'm going to go ahead and press approve. I'm going to throw in a comment. And then I'm going to press approve. Okay, so like I said before, the integration is configured directly within the Ion platform. You can actually go and see that integration is running. So like I said, I've set up the webhook to push to, that internal iPaaS server. I'm not sure a lot of the details are as important, but what it's doing now is it's running through the logic that we set up and is pushing those parts into Ion. If there was ever an issue, we have advanced monitoring that can be set up on the Ion side to let you know if something hadn't gone through properly. But in this case, it did. So we got the green circle. Once you trust the system, obviously you don't have to check this as much, and you can hope and expect that your parts will show up automatically within your parts library.
Or hardly ever. If I may just add what Jackson just showed there, very, very powerful, because when it comes to, some of this event-driven structure, the APIs connecting, people, in the hardware operation may just expect it to work. And that's exactly, how it works. But when things do, appear funky, to be able to quickly diagnose and debug right from within the workflow is a very powerful capability that Jackson just showed here. So that's an important thing to note, is that this is really being able to peel back or open up the hood and see what's going on. But in most cases, it just works, and so Jackson will show that here in a moment.
Right. Yeah, that's definitely, good clarification, right? I'm trying to just be transparent with everything that's happening, and I think, like you said, peeling back the layers, in the past, especially with working with consultants, they have this sort of fabricated barrier to understanding what's actually going on in their integration, and oftentimes want you to reach out to them, or set you up with some sort of TNM to get the lowdown. So we've basically broken down those barriers to allow people to go in and see. But he's right, in most cases, like, this is going to show up as a successful execution, and now my parts are in my library. So you can see the bearing assembly now exists along with all of the subcomponents for that particular assembly. And now I can click into this component and see that the bill of materials has a version, an mBOM version of 1. You've got 4 materials on here, each with the correct quantities. And this part is now available to go plan with using the Ion auto plan engine. You can execute purchase orders against any of these components or the assembly itself. You can go out and build this using our procedures and runs modules. And now your floor has the confidence to know that it's working with the right assembly, right? You don't want to work with previous revisions or get down the line and realize that a component hasn't migrated properly, which I believe is really one of the big key benefits of the integration, is that you're not going to miss or use the incorrect parts, right? Especially within the industries that we're working in, your engineering teams are moving so quickly. Your production teams are sort of on the end of that bullwhip, if you must. And having the systems talk to one another takes a huge load off of actually the communication between those two teams, and instead of waiting for someone to manually upload those parts when they're there for you when they're ready.
Yeah, if I can interject from my own personal experience, in my career, I worked predominantly with manufacturers in China and Shenzhen, and we didn't have anything like this, right? And even if we had a PLM system, it certainly wasn't connected to their MES or their factory management, and it was all done through email. Even if we did put it in PLM and gave them access, they'd still have to manually download it, and often they would even just circumvent that and say, just email it to me. And so it was literally like you're just sending it and crossing your fingers that they grabbed the right email, or that the right person was on their email distribution lists and saw it. You have just no idea what happens. And so the fact that not only the simplicity of setting this up, how quick it is to integrate these two tools, but the fact that you have this digital link and traceability of exactly what's transferring between the systems, it's incredibly comforting. One of the largest contributors to manufacturing mistakes is just simple human error of grabbing the wrong information. And this just completely eliminates that, like just takes it right off the top of possibilities of what could go wrong in manufacturing. And, I get jealous of our customers that they get access to this capabilities now. Like I'm not developing hardware, working in the trenches like I used to. And like this stuff, it just makes me cry, like how much better the world has become for being able to have access to this kind of content.